Thank you. Yeah, hello.
Thunderous applause. Thank you, Daniel.
Yeah, hi, I'm Andre from Green Hill Software, and I don't have any notes for what I'm talking about. Everything I talk about is around the number 2. You will figure out what I mean with that. So I want to talk about 2 things today. The first thing is, who is Green Hill Software? And the second is, how does Green Hills contribute to the Rust development ecosystem? Before I start with one, who of you knows Green Hill Software? Can you raise your hand? Oh, that's already quite a few people. Great. So let me quickly say who Green Hills is. So Green Hills started as a compiler company more than 40 years ago. So our first compiler was for the 68,000 CPU family. And one of our first customers was Apple, because they needed a C compiler for their Macintosh. But since then, we added more products like source code debugger, trace debugging, debug hardware and trace hardware, as well as real-time operating systems. We do actually have 2 real-time operating systems. One is called Microvelocity, which is for microcontrollers, and one is called Integrity, that is for the microprocessors, which have an MMU. And I will talk about this later again. So this is on a very high level the summary of the product portfolio from Green Hills. So let's come to the second point. How do we contribute to the Rust community? So there are basically 2 technologies we are also showcasing here on our demo. The first one is our real-time operating system Integrity, which is very well fitting to run Rust code in a process. And that is for 2 reasons. One is the API, the native API of Integrity is very well matching to all these mechanisms that Rust wants to have in a runtime environment. So we have a very efficient binding between your Rust code and the API and the functionality of the operating system. The second thing is that Integrity itself is a separation kernel. What does that mean? That means you can run your trusted code, your Rust code that you really trust, that is well designed, next to untrusted code, maybe some dumb C code or code that you got from a third party, which you don't know if it really works. And they can run on the same CPU, and the Integrity OS makes sure that they run free from interference. So whatever the untrusted code does, whatever it crashes, your trusted code still runs. And that's a real powerful capability of the real-time operating system. The second technology we showcase on our stand is our tooling around Rust. And there are 2 interesting features to talk about. One is we have the capability to provide you source level debugging in a like JTAG debugger, for example. You connect to your target. You can debug your Rust code, see strings, variables, everything. You understand your code very well in this area. So that's a part of the offering. And the second part is we have the trace technology to generate trace data or to collect trace data from the target and then visualize the trace data, because the visualization of the data is a very important part of understanding what your system does. I mean, if you get log messages and you see like thousands of messages, you scroll through them and say, yeah, I think I get what it's doing. But if you see a picture of what's going on, if you see a pattern of how your program works, you can very quickly identify if there's a place in your code where it doesn't work as expected, and then you can dive into that, go to the source code and fix the problem there. And that was, on a high-level summary, what I want to talk about. Thank you very much.